Imagine a high-speed mechanical sorting machine processing thousands of items a minute. A miscalibrated sensor misinterprets a shape, and the machine violently jams, crushing everything. This maps precisely to what happens when you deploy an AI agent against traditional software. Picture an agent with access to 50 different tools: internal microservices, third-party APIs, billing systems. A user gives it a simple instruction: deactivate the trial customers from last week. The friction starts immediately. The agent has to parse tool descriptions originally written for human developers, scanning paragraphs of prose to deduce how the system operates. It reads through the available options and discovers two endpoints with nearly identical descriptions. Confused by the ambiguity, the agent hallucinates a parameter name, bypassing the deactivate function entirely and executing a call to delete. The endpoint returns a 500 error, which the agent interprets as a network issue.
It tries again and again. Soon, red alerts flood your logs. The agent is in an endless loop, burning thousands of tokens and corrupting database records. The compute cycles and latency spent guessing how to use software instead of executing the actual task is the AI cognitive tax. The tax exists because we force autonomous models to operate on infrastructure designed for human intelligence. A human developer interacting with an API relies on context. They read the documentation, navigate Swagger files, and pull examples from Stack Overflow to bridge the logical gaps in an endpoint. Agents lack this intuitive context. They cannot safely interpret conversational docstrings or reliably adhere to advisory text warning them against certain actions. When agents inherit interfaces that require interpretation, the resulting guesswork leads directly to heavy token usage, severe latency spikes, and destructive real-world actions. To eliminate the tax, software boundaries must transition from being interpretable by humans to being instantly perceivable by machines. Historically, software has relied on two specific bridges to interact with the outside world. The first is the user interface, explicitly built to render pixels and layouts for human eyes. The second is the application programming interface, built to serve structured data wrapped in prose documentation for human developers. Autonomous agents fit neither of these categories. They require strict intent and explicit constraints alongside the raw data shape. An agent needs an absolute schema to operate safely. It bypasses pixels entirely and cannot parse subjective prose. This requires the apcore standard. It acts as the third bridge, an interface designed strictly for machine intelligence. It does not replace your UI or your API. It sits alongside them, providing the exact structural substrate needed to support an agent economy. The apcore module standard takes opaque blocks of code and turns them into direct, machine-readable capabilities. It achieves this by forcing every module to adhere to 4 non-negotiable properties. The first property is the mandate for strictly typed input and output schemas. These schemas are enforced exactly at the executor boundary. There are no optional parameters. This rigidity explicitly eliminates the ambiguity that causes model hallucinations.
The second property requires a plain text description, strictly capped at 200 characters. By keeping the text brief, the model relies purely on a clean, indexable table of these concise descriptions for accurate tool discovery. The third property is the requirement for behavioral annotations. Before an agent invokes a call, these tags ensure it learns the exact physical consequences that action will have on the real world. The fourth property is a directory as ID addressing system. A file's path is its absolute identity, completely removing the need to maintain manual registries. Combine these 4 properties, and an agent never has to guess how a piece of software works again. These properties form an uncompromising set of execution constraints at the baseline of the standard. Optional safety is unacceptable for autonomous execution. Every intermodule call operates on a default to deny access control policy. Any cross-communication is explicitly blocked by default. Default allow environments are exactly how agents find unauthorized pathways to wire money or delete databases maliciously. When an agent attempts to trigger a module labeled as destructive, the protocol pauses the entire execution loop and awaits human approval. Irreversible actions require human intervention at the deepest foundational layer of the standard itself, rather than as an afterthought in secondary application logic. Furthermore, the standard mandates end-to-end observability. Every call carries trace context, and every step emits structured events. If you lack strict auditability at the module boundary, the term autonomous is simply a synonym for unsupervised. There is a professional misconception that adopting a new AI routing framework or context protocol alone can secure an agent's actions. To clarify, apcore is not an AI framework. It does not route models, it does not prompt LLMs, and it does not replace protocols like MCP. Current protocols like REST, gRPC, A2A, and MCP exist in the middle of the stack. They are the transport layer. Beneath them is the execution layer. This is where apcore lives, standardizing and constructing the module logic beneath the transport protocols. You write a single apcore module definition, and that logic automatically fans out universally across all transport surfaces simultaneously. Transport layers dictate how systems talk to each other. Apcore strictly defines what they talk about. We are entering an operating environment where the vast majority of software will be invoked by agents rather than human operators. The thinking layer of this economy is centralized, heavily commoditized, and controlled by a few large model providers. But the real world is decentralized. The execution layer, the space where real money moves and data is actually altered, must remain open, governable, and exceptionally rigorous. This requires minimalist governance. Apcore operates as a public Apache 2.0 standard built on a single specification document, supported by unified TypeScript, Rust, and Python SDKs. The specification is open today. Build a module and test exactly what a true machine-perceivable interface feels like. We cannot build an agent economy on interfaces written for human readers. Abolishing the brittle, human-centric middle layer is the only way the AI cognitive tax truly comes off.